So today I'll be working on number 17 from the first exam test. So the number 17, it goes, a person is riding in a hot air balloon. For the first hour, the wind current is a constant 9.75 miles per hour in the direction of north 37.5 degrees east. So let's label this. Let's just label our coordinate, and we have this. This is north. Never eat soggy waffles. Alright, so it says that for the first hour, the wind current is blowing at a constant of 9.7 miles per hour in the direction of north 37.5 east. So north 37.5, so northeast. So we're going to be in the first quadrant, and this is not to scale, but we'll just do this. And the first thing we have to know is that we always attach the angle to the y-axis. So this angle right here will be 37.5 degrees, and this line is the distance, which is 9.75 miles. So we'll do that here, 9.75 miles. Then it goes on to say that the wind current changes to 4 miles per hour and the balloon heads in the direction of south 52.5 east. So because we're not going to start here again, because the hot air balloon moved up, and from this direction we're going to draw another coordinate plane right there, and it same thing, never eat soggy waffles. And we see that it changed direction to south 52.5. So this is the south and this is east. So we will be in the fourth quadrant for our second graph right here. So then changes directions right there. So that's our line. And again, we always attach the angle to the y-axis. So this angle would be to this y-axis, and it would be 52.5 degrees, and yeah, so 52.5 degrees. Then they also said that if this continues for another 1.5 hours, how far is the balloon from the starting point? Okay, so this is the starting point. And remember, the hot air balloon traveled up, changed direction, boom, we ended here. So they're asking for how far is from the starting point, and I'm going to put this in a different line, I'm going to put dotted lines, to this point right here. So they're asking for this line right there. So first we have to realize that they said in the beginning that they changed directions and the wind current blew 4 miles per hour. We know that before, when the wind current changed to 1 hour, we know that before that they only traveled for 1 hour. And now that for another hour, they traveled for another 4 miles. So since they said that if it continues for another hour and a half, then we're going to add 2 more miles to the 4 miles that they already flew. So it changed to 4 miles, and we're going to add another 2 miles because it's an hour and a half. So the 4 miles is now 6 miles, which is this length right here. So it'll be 6 miles. 6 miles. So we can easily just look at this as a right triangle, and we can do the Pythagorean theorem. We know that this side is, we know that this side is 9.75 miles. This side is 6 miles, and we're gonna use this as the hypotenuse because this right here is a right triangle. Yeah, it's a right triangle. And I'll draw it here so that it'll look, so boom, right triangle. We need to find this. This is 6 miles, and this is 9.75 miles. This triangle is just this. I just dropped it down so that we can see it easier. So the Pythagorean theorem, we know that 9.75 squared plus 6 squared equals c squared, which is our hypotenuse. We're trying to find that. 9.75 squared, I already worked it out earlier. It's 95.0625 plus 36, which is the 6 squared, equals c squared. Add that together, then you get 131.0625 equals c squared. We want to find c by itself. So to find that by itself, we square it. So we would find the square root of that. And we got 11.4 equals c. Remember that this c is the miles. We're trying to find the miles. So what we just found is that the distance from the starting point to the end of the hot air balloon is 11.4 miles. So that's our first answer, is 11.4 miles. And you can just put mi for the unit. The other question is, what is the bearing of the balloon from its starting point? So to find the bearing, we also have to find the angles inside of the triangle. We know that they gave us that this, triangle. Okay, so first thing we're gonna do is we know that this is 90 degrees. This is 90 degrees. And we can also, so what they want to do is we want to find this angle inside the triangle, and we're gonna add it to 37.5, which was our original length. So we're trying to find this angle right here. This angle is this angle right here. So we'll call it theta. We'll call it theta. Theta. So to find that angle, we'll do sine of theta. So sine, I say sine because we know that we have, let me label this, 0.4. We have all of the signs. So we can use any trig function. I feel comfortable using sine. You can use any function you want. So we're going to use sine, which is opposite over hypotenuse. So our sine of theta equals opposite over hypotenuse. So it's the opposite, which is 6, over hypotenuse, which we just found out, which was c, which is 11.4. 11.4. And to find that, we're going to use the inverse of sine of theta. So inverse of sine of theta is the -1. Sine theta, we're going to use the inverse. Sine of theta inverse equals 31.7. And that's after we plug this into your calculator. So we know that this angle right here is 31.7. 31.7, correct? And that's the angle that's just up here. Here, I'll label it here, 31.7. Now, our next step is to add both angles. This distance, northeast of 37.5, to our new theta, which was 31.7. We add that, so I'll do it here. 31.7 plus 37.5. And when we add that, you get 69.2. And what that means is that from the bearing of the balloon from its starting point, it went north. We're going to do north 69.2 degrees. east. And that's the answer. So we found that our side is, they traveled at 11.4 miles, and this is our new bearing. And that's how you solve question 17 for our first exam for trig. Thanks. And I'll show you the work a little bit.